If you would, turn in your textbooks to page 569. Page 569. Page 569. And your homework was to do page 569, numbers 1 through 22. Now, Scott, they both used a homework pass, which I will collect. Well, actually, I don't even need to collect it because it's no good after today anyway. So you can even keep it as a souvenir. Never be able to use it? Okay, I'll collect it from you. They're like, no, it's gratifying to hand it to you. You're trying to wound me. Yeah, okay. Staple stuck in. Whose idea was it to staple those things together anyway? Oh. All right, 569. So I'm just going to give you the answers, Scott, for 1 through 22. And if I feel like some commentary may be helpful, I'll run through it. Number 1, express x to the negative 10th using positive exponents. Remember, negative exponent means reciprocal, 1 over x to the 10th. There on page 569. 3 and 7/8 is a decimal. Remember, 7/8 is 0.875. So 3.875% with the decimal twice, 0.03875. That number in scientific notation, move it backward 3 times to get 2.4 times 10 to the negative third. Number 4, move the decimal backward 4 times to get a big number, 81,000. For number 5, you add to get 7 feet 18 inches, but 12 of those inches become another foot, so your answer is 8 feet 6 inches. For number 6, you don't have to write the answers in, folks. You don't have to write down the answers. Why? Why would you? Number 6, find the product of 3 gallons, 3 quarts, and 5. Well, you multiply to initially get 15 gallons, 15 quarts. But remember, 12 quarts is 3 gallons. So that becomes 3 more gallons to give you 15 gallons, and there's 3 quarts left over. So 18 gallons, 3 quarts, our answer. Number 7, we subtract, and we get 4.5 times 10 to the 8th. Really easy there. Number 8, remember you only combine like terms. So the 4a and the 7a combine to give you 11a. The 9b and the negative 1b combine to give you 8b. And then the plus 1 has no friends, so we just stick it on at the end. Number 9, evaluate if x is negative 4. Well, we square negative 4 to get positive 16. Negative 4 times positive 5 is negative 20. And then we add the 4 and we get nothing, 0. Our answer. Number 10, translate 3 less than twice a number to algebra. Lana, what would that be?
2n minus 3.
Good, 2n minus 3, or 2x minus 3, or 2j minus 3, or 2s minus, whatever letter you want to pick. 2n minus 3 is correct. And number 11, find the next term of the following sequence. 1, 2, 4, 7, 11. What's going on there, Josh? Do you notice a pattern?
They're like counting, like you do plus 1 and then plus 2 and then plus 3 and then
Oh, so the next one would be plus
5,
which would give us
6.
Good. My initial thought is doubling, right? 1, 2, 4, but then the double would be 8, and it's not. So it's like, well, you're not multiplying clearly. Plus 1, plus 2, plus 3, plus 4, plus 5, 16. Great job. Number 12, when you add, of course, get a common denominator before you add fractions to get 7 and 5/6. Number 13, remember you're going to multiply 0.4 times of 90 to get 36. Number 14, you're going to divide away the 75 to get 30 75ths, which reduces, by the way, to 10 25ths, which multiplied by 4 gives 40 hundredths, which gives 40%. Or you could just divide it and get 0.4. Number 15, remember you multiply by 3 to get 12 teaspoons. Number 16, fluid ounces to quarts. We never memorized that. But we do know there's 16 ounces in a pint. So if there's 32 ounces, that's 2 pints. And 2 pints is a quart, so 32 ounces must be 1 quart, using dimensional analysis there. On the next one, you're going from milli to hecto. Well, milli, centi, deca, or deci, unit, deca, hecto. We're going to move 5 places this way. And it's going to give us 0.00134. For number 18, we just get positive 6. Subtract, keep the sign of the greater. Number 19, we never subtract. We add the inverse. So add a positive 2 to get 7. Number 20, signs are the same. Add and keep the sign, negative 24. Number 21, anytime you multiply, if the signs are different, automatic negative, negative 20, our answer. But if the signs are the same when you multiply or divide, you automatically get a positive. So number 22 is positive 6. You guys, I ran through those for Scott's benefit, but as you were kind of looking at the problems, any questions at all on that? All of that we feel like, yeah, I'm going to be good with this next year in Algebra 1.
Like on number 17 with the metric units, how do you know like when it stops when you go over? Like you do the King Henry thing, but Like, do you stop after the number or before?
Oh, you go right to whatever. So we go once, twice, thrice, 4 times, 5 times. Right? You go right to the hecto, which happens to be 5 times after you move the decimal. So in the number 134, here's the decimal. So I go 1, 2, 3, 4, 5. And there's my decimal. But there's 2 gaps. So I fill in with zeros.
Yeah.
Yep. All right, good question. Good. Anything else? Any other questions? Again, that's something you're going to actually use more in science, physical science, chemistry, physics, throughout the rest of high school. We'll use a lot of metric that we call it SI, right? System International. It's what all the sciencey people use. Good. Any other questions? All right. Let's turn over to page 571. 571. I want to look at a couple of word problems with you here. Look at word problem 25, if you would, and read that for us, Lana.
One number is 2 more than twice as large as the second number. If the difference of the 2 numbers is 12, what are the 2 numbers?
All right, and so we've got 2 numbers. We've got a first number called 1 number, and we have a second number called second number. And which one should we choose to be x, Lana?
The second number.
Good, because it says 1 number is 2 more than twice as large as a second number. Since it comes back to second number, we'll let second number be x. Josh, how would I represent that that first number is 2 more than twice as large?
2x plus 2.
Good, 2x, that's twice as large, but 2 more than that means plus 2. Could you say 2 plus 2x? Yeah, addition's commutative, but again, get in the habit like Josh is, and when you see the word than, flip that order, get 2x plus 2. Good. And it says the difference of the numbers is 12. Difference is or equals 12. Lana, how would I show that the difference is 12?
What do you do, 3x negative?
Well, difference means subtract, right? So we'll take the first number, and we'll subtract the second number, and that will equal 12, right? The difference is 12. And so you put the first number minus the second number. Now, do we really need all these parentheses and stuff? No, we can take those off. And there's just an x in here, so we just take those off. In Algebra 1, we'll talk about what to do if there's more than just an x in there. And now we can do some combining. There's a 2x and there's a negative x, Lana.
3x.
Careful.
Negative 3x.
Josh, 1x. You have 2 x's, and we take away one of them. We have 1x left. If we were adding, we'd get 3x, but we're subtracting to get 1x. Now, the 2 has no friends, so we just write him down. Equals 12. Back to Lana for redemption. What do we need to do?
Subtract 2.
Subtract 2 from both sides. Of course, that'll give us 1x, but I'm just going to write x, because I'm too lazy to write the 1, equals 10. Which means, if x is 10, Lana, which of my numbers is 10?
2.
The second number. Second number is 10, and then what would the first number be, Josh?
22.
22. And there we go. Questions on that word problem? All right, let's skip over to 28 now. Josh, read this if you would, please.
Ivy bought a carton of 16 kiwi fruit and shared them with her sister Maisie. If Ivy ate 5 less than twice as many as Maisie, how many did each sister eat?
All right, and how many unknowns do we have, Josh?
2.
2, and they are
Maisie and sister.
Maisie. All right, that's with an S, isn't it? Maisie and Ivy was her name?
I think so, yeah.
Maisie and Ivy? All right, let's say it's not Holly and Ivy. All right, so Maisie and Ivy, or Maisie and Ivy, I don't know how you pronounce it. Who gets to be X, Josh, as you were reading that?
Maisie.
Maisie, because it says Ivy ate 5 less than twice as many as Maisie. Comes back to Maisie. We're going to let her be X. How would we represent Ivy? Lana?
2x minus 5.
Good, 2x minus 5. Now there's one number we haven't used yet, Josh, and that number is 16. There are 16 kiwi fruit in the carton. The only people eating these kiwis are whom?
The 2 girls.
The 2 girls. So if together these 2 girls eat the 16 kiwi fruit, what's our equation, Lana?
3x negative 5 equals 16.
Good. Now, it's because we would say that Maisie and Ivy together ate 16, so we would add them, but she's right. This time when we add x plus 2x, we do get 3x. Minus 5 equals 16. Of course, to solve, Josh, we need to
Add 5 to both sides to get 3x equals 21.
and then we can see that x equals
7.
7. So who ate how many?
Maisie ate 7 and Ivy ate 9.
Ivy 8, 9. That's fine.
Ivy ate 9.
It's 7, 8, 9. Anyway, Ivy 8, 9. Anyway, a stupid joke. Okay. 7 and 9 for Maisie and Ivy. Questions on this? All right, we'll be doing a lot of word problems, obviously, in Algebra 1 next year. Look at number 29. We want to set up a proportion here. There are 5,000 tigers left in the world, it's believed. A lot of them were killed off years ago by hunters who thought, ooh, that coat would look that fur would look really pretty in my house. And so they're now an endangered species, so we don't want to go killing off tigers, though if it's about to kill you, all bets are off. Though, why would you go where tigers are going to kill you? Anyway, but apparently only 4 out of every 100 tigers in the world are white tigers. The rest are orange. How many white tigers are there? How would we set up a proportion? What do you think here, Josh?
4 to 100.
4 to 100. Now, this is a ratio of what to what? 4 to 100 is a ratio of?
White tigers to regular tigers. Like
White tigers to, it's 4 out of 100. So 4 tigers are white out of every 100 total tigers. These are all the tigers in the world. 4 out of every 100 are white. So the other number they give us is
5,000.
the 5,000 is to represent white tigers, orange tigers, or all tigers?
All tigers.
All tigers. So the denominator, or the consequent, excuse me, over here is also going to be 5,000, and we're solving for the number of
white tigers.
white tigers. So we would say that white is to all as white is to all. That makes sense? Now, if it had been 4 white to 100 orange, then that would be white to orange. No, we'd have to do 4 to 104. Add them together to make sure we get all here to match the all over here. Does that make sense? And you might be able to use the equal ratio method here. Approximately, how many white tigers are left in the world? Solve. How many white tigers left in the world? Good, Scott, 200. We multiply top and bottom by 50, right? 50 times 100 gives 5,000, so 4 times 50 is 200. Very good. There's that human calculator award.
That's all it is, 200?
Apparently, that's what, I'm assuming their numbers are right, or close to right at least. About 200 white tigers left in the world. So if you see one, don't shoot it, just run really fast and get somewhere safe. All right, let's look at number 30, and read that one for us if you would, Lana.
George.
I think it's Jorge.
Jorge?
I think that's Jorge.
Yeah,
I think that's a Hispanic name.
It's Jorge.
Yeah. We got Josh agrees with me. It's Jorge. Josh knows.
Jorge just finished assembling the model of his favorite sports car. The scale for the model is 1 to 12. His model is 16 inches long. How long is the actual car in inches and in feet?
All right, so 1 to 12. Now, what is that 1 to 12 scale thingy they're talking about, Lana? When they say that a model is a 1 to 12 scale.
It's 3.
Josh?
I don't know.
Well, it means that the scale, the model, if it's 1 inch on the model, it'd be 12 inches on the real thing. 1 to 12 means the real thing is 12 times as big as the model. Does that make sense? So this is the model, and this is the actual real, it's a car, right? Model car? Yeah, the sports car. So for instance, if a tailpipe on a car is 24 inches long, okay, then it would be 2 inches on the model. That makes sense? 1 to 12. So it's a pretty big model, apparently.
Yeah.
All right? In fact, how big is the model?
X 16 or 16.
Which one is it? You know the number. You know the number they gave you is 16. What does the 16 apply to? So where should the 16 go? The top, because that's where model goes. So model is to actual as model is to actual, and the question is, how big is the actual sports car? So that's where we should put our X. Do we remember talking about this back in the day? Just make sure the ratios are set up to match this to that, antecedent to consequent, are talking about the same thing each time. And cross multiplying is probably the quick way, because 1 times X is just X. So really you're just doing 12 times 16. 192. Good. 192 inches. There we go. And it says we want it in inches and feet, because let's face it, nobody thinks in terms of 192 inches, right? That's so many inches. Let's think feet.
So
Divide by 12. Good. And don't make this too hard now. 12 times 16 gave us 192.
Oh,
so if you divide by 12, you're going to get 16 feet.
I didn't even think of that.
This is where mathematicians can be lazy, because mathematicians see things like that. And that's how we be lazy. All right, anyway, throw that thought out there. Let's go ahead and look through some things very quickly here. You don't need to write these down, just call them out. This is a true-false section. Number 31, true or false? Algebra is the study of the properties, measurements, and constructions of figures. Geometry. Good. Number 32. A line segment is a portion of a line having one endpoint and extending indefinitely in one direction from the endpoint.
Ray.
That's a ray. A ray, you know this is false now, because we just had ray, is a length made up of points that extends indefinitely in both directions. Line.
Oh.
Perpendicular lines are intersecting lines that form right angles.
True.
It is true. Perpendicular means they make right angles with each other. Let's see. Two-dimensional figures like angles, triangles, and rectangles are called plane figures. True. What would we call boxes and pyramids and stuff? Three-dimensional or solid figures. Solid figures.
Yeah.
Let's see. Polygons include shapes like circles and triangles.
True.
Half
Yes.
true.
Well,
Polygons include triangles, but not circles. A circle is just called a closed figure. A closed figure. Yeah, it's definitely, polygons, remember, have to have sides, straight lines form them, and a circle is not made up of straight lines, so circle can't be a polygon, but it is still a closed figure, like a triangle. I'm sorry?
Is it a circle? No.
Well, a circle is technically, we would technically call it a closed curve, because, for instance, that's a closed figure also, right? It's a closed curve. But well, imagine that's a straight line there. That's a polygon. It's made up of straight lines. It's still a closed figure. That's a closed curve. That's a polygon. Anyway, number 37. A hexagon is a polygon with 7 sides. Heptagon, they lied again. A rhombus is a parallelogram with all sides equal.
Square. Oh, wait, no.
So picture a parallelogram. You know what that looks like, right? The parallel sides. But if the sides are all equal, true or false, that's a rhombus.
True.
True. That is a rhombus. A rhombus is a parallelogram with all sides equal. Number 39, a polygon that is both equiangular and equilateral is called a regular polygon.
True.
That is true. So all the sides equal, all the angles equal, like the equilateral triangle, is a regular polygon. So would a rhombus be a regular polygon? No. All the sides are equal, but the angles aren't, right? This is acute, that's obtuse. But a square would be a regular polygon, remember. Let's see here, the next one. Triangles can be shown to be congruent. Ooh, it's been a long time since we looked at this. Using side, angle, and side angle. Side is the last way. Good. In fact, side angle is something they talked about. We did not, but we'll talk about it more when you get to geometry. It actually could define 1 or 2 triangles, or in some cases, no triangles. So, yeah, side angle, not a way to show triangles congruent. Number 41, triangles can be shown to be similar using angle. True. In fact, that's all we ever used was angle. And then a right angle has 90 degrees.
True.
That is true. Next page, let's keep going. The area of an equilateral polygon can be found by multiplying the number of sides by the length of one side. Perimeter. Good, we're talking about the perimeter there. An obtuse angle is between 180 degrees and 360 degrees.
True. Wait, no.
No, obtuse is between 90 and 180. What's between 180 and 360?
Is it the one that goes like?
Yeah, it's the one that goes down beyond.
No,
Like the angle here is greater than 180. Kick the doctor when he hits you in the knee. Reflex angle.
Oh, yeah.
Remember the illustration, the reflex angle? Yeah, so that's what I always picture is your leg kind of hanging down and then the doctor hits it, you kick him in the face. But anyway, reflex angle. See, adjacent angles between 180 and 360. Reflex. 45. Adjacent angles are two angles that have a common side between them and share a common vertex. True. Transversal is a line that intersects two or more other lines. That is true. We haven't looked at that in a while, though we will in just a moment. In fact, if you look across the page, you can actually see a couple of parallel lines, G and H cut by A, transversal. We'll look at those in just a moment. I know. We're just refreshing some things. And again, not so much for the exam, but for geometry. These are all things that, hey, if you can remember them going into your junior year, man, geometry is going to be so easy for you. But if you have to relearn every one of these things, that's going to be a lot to remember because we move fast in geometry. Number 47, a quadrilateral that has only one set of opposite sides parallel. So the parallelogram, both sets are parallel. What do we call something with only one set of parallels? Trapezoid, good. Let's see, 48. What are two rays that share a common endpoint? Two rays that share a common endpoint. So ray out that way and ray out that way from the same endpoint. An angle. An angle. Yeah, don't guess. Picture it. Again, that's what you have to be able to picture. Okay, endpoint, two rays. Oh, that forms an angle. Right? Just like, okay, only one set of parallel sides. Those two are parallel, those two ain't. Oh, that's a trapezoid. So picturing it in your mind is what's key right now. And Josh apparently is very good at picturing things in his mind because he's nailing these. Let's see, number 49. Lines that never intersect each other.
Like the ones that there's two and it just goes straight. Can't forget.
Never intersect.
Perpendicular. Wait, no.
Parallel lines. Yep, we just looked actually across the page at some parallel lines, G and H. Let's see, two polygons with the same shape and size. Congruent figures, very good. Let's see, number 51, what would we call that thing? Line Z. Right? Line Z. Let's see, number 52, what would we call that thing, Lana? Two rays that go from a common endpoint. Angle. What angle? Let's name it.
Angle BCA. Well,
not BC. Oh, it does matter. It does matter. Careful. Look at it again. ABC or just angle B. Good. You can name it by the vertex and just call it B, or ABC or CBA. There we go. But not BAC or BCA. Let's see, number 53. Now, those lines form right angles, so those lines are class perpendicular. How would I write that out? Kind of tell me what to write down here, Josh.
Line X, Y.
And remember, for that, we'll just put a line across the top of it. Okay, so line XY.
Line XY is perpendicular.
And what is that perpendicular thing?
Upside down T.
Good, an upside down T.
And then, line U.
There we go. Now again, in geometry, when you get to 11th grade, we're going to ditch the line across the top because we assume if I'm giving you two letters, I'm talking about a line. Because if you have 2 points, what goes through 2 points? A straight line. So it's assumed straight line. So we're actually going to be even lazier than this when you get to 11th grade, but you're not there yet, so you have to do the work and draw the little arrowy thing at the top. Wow. All right, number 50. Can you tell I junior high, I'm like, man, this is rough. I got to draw all kinds of stuff I'm not used to. I like being lazy, and they're making my life harder. All right, number 54, Lana. How would we write what we see in the picture there?
Line GH is parallel.
And what's that parallel symbol?
It's like an 11.
Right, it's the lines I was trying to show earlier, right? It's those. Now they're a little taller and a little deeper than the 11s. They go a little higher than the letters, where if I were writing an 11, I'd make it the same height, right, as the other letters. Okay, so line GH is parallel to?
Line KI.
Good, easy enough. What would be the symbol for line ST, Joshua?
Just the line at the top of ST under it.
Yeah, one of those with the capital S, capital T under it. And then ray CD, Lana.
A point with a line.
Good. A line symbol, but only the arrow at one end, not at the other, and then below it,
The CD.
CD. Now, if the end point was D, we would call it DC, so that whichever letter is listed under the end without the arrow is the point, and the other point happens to be somewhere along the ray. Let's see here, number 57. Number 57. Actually, let's do it. Have you do 57, 58, 60, and 61. 57, 58, 60, and 61. All right, so it's kind of miscellaneous geometry stuff here. So you got some similar polygons. We actually just did one of these not long ago.
Yes.
That's what I'm talking about.
Yeah, so that's why I picked it, because I'm like, she needs help with this. She needs to know how to do this. This could be good for her.
Pretty good at them.
I gave it to you so you could prove to yourself, you know what? I do know how to do this. I can leave this class with confidence instead of shaking in fear of something as insignificant as that little pink polygon.